Good morning, folks, and thanks for joining us today. This is the first lightning talk. This is the first lightning talk in our Experience First Data Center Networking series. Today, we'll talk about modern data centers architecture with Apstra. My name is Majid Ansari, and I'm an architect for Cloud Vertical. With us, we have Jeff Doyle. We all know Jeff, and thank him for educating us through the years with his books, trainings, videos, and blogs. Thanks for joining us, Jeff. So today, we're going to talk about data centers. Data centers are rapidly growing in recent years, and this growth is expected to continue. It means existing network operators and architects will have to do more with less. Our goal today is to offer a solution for your modern data center challenges so that you don't have to make trade-offs between agility and reliability, deal efficiently with operational complexity, and reduce constraints so that you can make your technology choices without constraints. We have two more upcoming sessions, one focused on day 2+ operations and another one on APIs and automation. We would like it to be more interactive, so feel free to put comments and questions in the chat. We'll try to get through as many questions as possible towards the end. And just to make it easier for us to deal with the questions, just maybe prefix it with a Q or something so that we can easily find it through the chat. But definitely comment as we go along. Let's jump right in quickly on what we plan to cover today. We will go over the needs for a modern data center and then how EVPN addresses them. We'll talk about essential characteristics of a fabric management solution, like what you need to look into a solution when you're deciding to go for a fabric management solution. And then we'll have Jeff go over how to operate an EVPN fabric using our intent-based approach. So first, let's talk about modern data centers. Obviously, hyperscalers have set a gold standard for modern data centers. And looking at that, looking at the success they have, everyone wants to build a reliable and efficient and scalable data center like Amazon or Google, right? However, we don't operate on the same ground. Most of the organizations building data centers face unique challenges, right? They need to build a modern data center, but at the same time, they need to support legacy applications that may require layer 2 stretch. While their modern applications are talking on IP, right? So you need a reliable and efficient infrastructure that can support both layer 2 and layer 3. Now, when you're supporting these layer 2 stretches, right, you want to be able to have any VM or any host in any rack. You don't want to be reserving those rack spaces for, to be on the same subnet. That means that you want it to be on any rack or anywhere you want it to, right? There's also a need for having physical infrastructure shared among ports or applications that would sit on the same hardware, but at the same time, they cannot talk to each other. They need to coexist, but you may want to isolate it using VRF-like construct, or you want to have some of those flows directed through the firewall. And that way you can have that secure communication going through. If that's not enough, we actually have modern infrastructure going using microservices and virtual machines. They add a unique challenge to the network. There is a constant change in IPs and MAC addresses that is going on in your backend infrastructure that is outside of your networking element. And that means that your network has to now react to those changes and adapt to those changes without making any configuration changes on the network. And all these things need to happen on, a simple IP forwarding infrastructure that is affordable. You want to be able to use simple IP forwarding hardware wherever possible, spine, super spine, or core of the network, while your edge of your network is doing intelligent things like the things I described above. This is not a complete list, but I just try to highlight some common scenarios. If you have seen any other challenges, or if you want to share something that you are running into, please feel free to put it in the chat, and then we'll try to get to it towards the end. So while we looked at the challenges, right, I think we are in luck because EVPN offers a standard-based and interoperable solution for some of the challenges that I highlighted. We can just talk along about EVPN, but let's quickly see how it solves a problem we discussed earlier, right? So first, it uses BGP protocol for signaling. BGP, as we all know, has proven over time. It can carry large scale, like internet scale, or even bigger in some service provider network. So it is scalable, and it will meet your scalability needs. While BGP is doing it, we also talked about being able to do layer 2 and layer 3 extensions. EVPN is able to do it. EVPN is able to offer you both L2 and L3 extensions using the same EVPN-VXLAN technology. With BGP now, because signaling is happening in BGP, you don't have to worry about flooding like you have to worry about in a spanning tree network. You get your traffic loop avoidance built in, and with all that characteristics, now you can scale better, right? You can predict your scale as well, and not worry about loops and things like that in production. And beauty of EVPN is it comes with a lot of things built in that in past needed their own protocol. So for example, right, you get all active multipath. Now you don't have to block ports and then worry about losing ports in your steady state. You can use all your links and do multipath and then forward traffics on all links. ESI lag, which basically offers you multi-homing, not only two routers or 2 switches, it can do more. It comes built in with EVPN. And in past, you would need, it eliminates the need for proprietary mechanisms like MC lag or M lag. Now it just happens in an interoperable way with EVPN. And I just want to also add that it eliminates the need for a chattier VRRP protocol. Now you can do simply using Unicast gateway, and then you now don't need EVRP across the network. So EVPN just has like some of these things is just built in. And it also meets your requirement of traffic isolation. Now you can use L3 VPN-like isolation using same BGP route target communities, and it's very easy to forward traffic through firewalls using the same mechanism. So you get your secure communication, and using a VXLAN overlay, which is simple IP UDP packet. You can now actually use it on simple IP forwarding infrastructure where you can like spines or cores, and then your intelligence lies on your edge switches that take care of all the EVPN functionality. So overall, I mean, EVPN I think is a pretty good go-to solution for the requirements that we talked about in a modern data center. Again, if you have any other challenges that you think that EVPN can solve for you, or you have or not able to solve, please feel free to add it in the chat. So we talked about EVPN, how it elegantly addresses your complex requirements, but you still need to manage your resources and logic for those complex requirements, right? You still need to ensure the network is operating with all those complex requirements. It's doing intended things, and then your maintenances are smooth, and the network, if something fails, you kind of know things the way they are. So I think you all will agree that it's very difficult, if not impossible, to do it manually. But I would also like to say that traditional automation will also not be able to cope up with it. You actually, and we strongly believe that you need a sophisticated fabric management solution to manage your modern EVPN data center. Let's look at some of the essential things that you need to look for, right? Whether you're building at home on your own or you're buying off the shelf, there are certain things you need to look at in an EVPN fabric management solution. So first and foremost, right, it needs to be easy to use. I think there's be no disagreement on that. And it needs to be multi-vendor. You shouldn't be logged into a given vendor when you are building a management solution. You should be able to simply declare or show your intent that, hey, this is what I intend to do with a VPN should go from here to here, or these hosts should be allowed to talk to that host. And the tool itself needs to be able to figure out what configuration goes there depending on the vendor, what best practices needs to be included in that. The tool should be able to do all that, and you shouldn't be burdened with figuring out the configuration and things like that. And I think the main thing is you shouldn't be like looking at something that just slaps CLI configurations that would manually, you would do it. And then expect it to, reduce complexity, right? It's one of those examples like, you probably heard when people were asked, if people were asked for a faster mode of communication, they'll probably ask for faster horses. But we know that you need to solve it elegantly, like a car is, as we know today, is a much more elegant solution, but it requires out-of-the-box thinking. So that's where you need a tool that takes care of intricacies of what you need to do. It needs to allow you to do more while you're investing less in worrying about the complexities. You just focus on your business needs. So that was like, I think, the first and foremost thing you need to look at. The next is, right, while we are operating the network, I think it's very important that we have all aspects of your network lifecycle covered, right? You need to be able to decide like what you want to do, then deploy it, and then see it in operational network, and then provide that feedback loop back if something goes wrong, right? And it's actually doable, and it's easily and most effectively done if your architecture and operation teams get the same pane of glass. So that way they do what they want to do, and then they can actually see what is deployed and operated. So a unified solution, you need a single pane of glass to do your network life cycle across the life of your network. The next, you want to be able to know like what's going on in the network, right? I mean, that's the only way you will be able to figure out what's going on. So what you need is you need you need to collect the right set of information, analyze it, and then present in a way that's useful for the end user, right? And the thing is, like, it needs to be on time. You don't want to be like, knowing about something went wrong 2 hours later. You want it to be immediate. And it also needs to give you context, because the fabric is so big, it will be hard for you if you just had sea of errors coming at you. You need in context so that you can take, precise actions. And all these needs to be done obviously in a modern way. So that way you can, you can query and then get the information you need. The next item is dealing with change reliability. I think this is probably the most important aspect of operating a modern network smoothly. You need to be able to have all this information that's going on in the network, but in order to offer it in context and provide you the root cause in a timely manner, you need to store it in a way that's easy to query, even though there are these relationships that are very complex and maybe not even known ahead of time, right? So something like a graph database, right, that allows you to have this complex relationship and then easily query them to figure out what's going on. I think it's crucial for success. That way you get information on time. You can look at things and then prevent risk of widespread outages and breaches, right? If you get the problem right and in a precise manner. So that's one of the critical aspect. But last but not least, right, it needs to be automation friendly. We all know that most of the organizations, they will operate a large infrastructure on top of the network. So they basically preference on what programming language they use, how they their workflows are, and then what OSS, BSS systems out there, right? So you want to be able to have that flexibility. So APIs and simple and usable APIs is a must. That way you can easily integrate with your existing systems and backends. And then you can do what you want to do and focus on your usual business while the tool takes care of it. So in summary, I would say, with a sophisticated tool, you actually will get to operate a smooth operation, or using a sophisticated fabric management tool. You would get a good experience, and then you can grow without growing pains, right? So I think keep in mind all these things that when you're looking for a tool. I would say, put things in comments if you think there's something else that is more important, or if you think some of these are not applicable to you. But after establishing that, I think I'll hand it over to Jeff so that he can, walk through a solution that we can offer that would not only meet but exceed, some of these expectations we have for the tool. So Jeff, I'm going to pass it on to you.
Great. Thanks, Majid. I'm going to skip the slides that I was going to present because I think Majid did a great job of really summarizing both the benefits of VXLAN EVPN and also the challenges. And the major challenge is that it's very complex to operate manually, or even with some homegrown automation applications. And so what I'm showing here, hopefully it's my screen is showing, is a Juniper Apstra blueprint of working, well, in this case, not a working network, but a network. And I've got a couple of different blueprints running in a couple of different labs that I want to talk about. And because we're really talking about operations and day two complexities, I won't spend more than just a couple of minutes talking about really how this particular blueprint is assembled. But I do want to say a little bit about it, because I think it's important to say, okay, how did I get to this point? And what you can see here is a fairly simple data center topology with 2 spines and 6 racks. There's 5 server racks. And in this, you can see, we say there's 24 generics. Basically, these are 24 servers. And I created this pretty quickly. And the other rack here is a border leaf rack. And by the way, there are redundant top of rack switches in each one. This border leaf provides outside access. The 2 generics here are firewalls. And there's also 3 access switches, which just extends access out. What's important to note about this is that when I built this, I built it by specifying just logical devices, an abstraction of the switches I want. So, I specify for my spine switches, I want a certain number of ports and a certain number of port speeds. For my top of rack leaf switches, I also specify I need a certain number of ports and a certain number of port speeds. And then I create a template that specifies how all of this ties together. At no point in there, at that stage, do I actually make a selection of what specific vendors I'm using. I only do that after I know that the blueprint that I want to use is actually working. And you can see in this diagram with everything put together in a blueprint, I also specify what resources I'm going to use. I specify pools of ASN numbers, loopback IP addresses, link IP addresses. I do that in a separate menu, excuse me, that then tells Apstra, this is the pool of resources I want to use for this specific data center. And I don't have to make any choices beyond that. Apstra will take care of managing that. If you have an outside resource management platform, like IPAM, obviously, we can connect to your IPAM system through APIs to further manage those resources. Only when I have all of that put together would I actually decide what vendors I want to use. In this particular case, for my spines, you can see here that, and I'm doing this specifically to show our vendor independence. It's only after I specify, what my topology looks like to answer my specific data center needs, do I look to see what vendors will meet that. In this particular case, on spine 1, I have a Cisco NXOS switch. On spine 2, I'm running Arista. For my leaves, I have a mixture of Cisco and Arista switches running here. And for these 3 access switches, I'm actually using Juniper EXs. But so those are already selected, but you can see that, for my spine switch, I specified for my spines, I want 32 40 gig links, and I get a list of the various switches that meet that requirement, which includes the Cisco that I chose and the Arista that I chose. So I'm selecting my vendors according to my specifications there. So that's just, there's a lot more that I could, maybe one thing that I should mention is once I have my vendors selected, I can actually get a cabling map, and Apstra will take care of actually telling me what ports to cable to what ports. And I can not only get that within Apstra, I can export that. Actually, I intended to, let's try that again. I can export that as CSV, which will fit into any Excel, any spreadsheet. So for example, here I'm using Google Chrome, and I can, there it is. It took a minute for that to process. I can print out an actual cabling map that my data center technicians can take, and when they rack up the specific devices, it tells them what interface to connect to what interface. And this is a verified cabling map. We can also do things like affinity checks, so no 2 connections are in a common failure domain, or sharing a transceiver, or anything like that. So all of that is verified ahead of time. But what's really important is, let me get this. Oh, there we go. Because we're emphasizing operations here, what's important for operations are 3 parts. It's the day-to-day configuration changes that you make in your network. It's the day-to-day information collection that you need to make about your network, and when there are anomalies in your network, you need to be able to quickly resolve those anomalies. And all 3 of those things are our day 2 operations. So just to show a little bit of that, going back to, I've got my physical view here, and this topology that I created, but then I want to, just as an example of day 2 operations, I want to start creating some virtual objects within this network. So the first thing I might want to do is create a couple of routing zones. And one of the things, maybe I should have kept a couple of slides. One of the things I do want to show you, just from a slide here, is this is from another lab that I put together, and I've got a sonic configuration, or a snippet of a sonic configuration, a snippet of NXOS, and a snippet of EOS. And the question that I posed up here is, well, do all of these things do the same thing? The answer is yes. And I'm not sure how well that shows on your screens, but what you can tell in here is that these are all configurations for a VRF named VRF Blue. But what is significant is when you look across these, they are very different configurations in appearance. And the thing is, they do actually all do the same thing. These are all Apstra generated configurations, and that's the important point to make here as I go into this piece. So let's say on routing zones, and you saw that configuration for a routing zone. Let's create one or two, and maybe I'll create a routing zone called blue. I could, if I want, specify my VLAN IDs to be used here, my VNIs. I set my routing policy, and I could choose my import and export route targets, very specific and very important for VXLAN EVPN. But I'm not going to do any of that. All I'm going to do is give it a name, and I'm going to let Apstra take care of all the rest of it. So I'll hit create there. And I'm going to create one more just for the fun of it. Let's call this one green. And the same thing, I'll let Apstra take care of all the other choices in there. And here you can see that blue is created and green will pop up in a second. And it will also figure out the route targets, not quite there yet. And you'll specify the resources you want to use. So in this case, I'm going to say for my loopback IPs, I've got a resource that I've called datacenter 1 loopbacks. I'll use that. For green, I also specify my loopbacks. And for my L3 VNIs, I have a pool of VNIs that I've specified for data center 1. And I select all of those, and everything should go green, and we're ready to go there. And you can see that actually took a little longer than I expected, but you can see that Apstra has specified my route targets, my VLAN IDs, and my VNIs for those 3 VRFs. What we call routing zones are just VRFs. So then I can specify some virtual networks, and I'll just do a couple here, but the point here is showing how fast the operations go. So I have let's call a VXLAN, and just to be a little whimsical there, I'm going to call it Stan. And I'm going to put that in that blue routing zone that I just created, that blue VRF. I'll let, again, Apstra take care of making all the choices about VNIs. I can specify that I want the same VLAN ID on all leaves. I want DHCP enabled, and I want to tag that. And then I can specify what racks I want that VTEP to appear on, and I'll create that. And I'm kind of doing this randomly, so it'll be interesting to see if I manage to do this with no mistakes. One more VXLAN just to show, and we'll call this one Ollie. Again, let's put that in the green routing zone that we just created. Specify again that it's tagged, and let's say that's going to appear on the border leaf and on these first 3 server racks. And again, I'm just quickly making choices there. And then I have to specify my SVIs. I've got an SVI pool here. So I'm not actually specifying any of this. I'm just telling Apstra the pools that I've created ahead of time. Select your SVIs out of that pool. So VNIs, and we got a little spinny wheel here for a second as things process. I specify that. I specify my VTEP IPs. And at this point, everything should go green. And let's see, it will quickly go, there it goes. What's happening in the background when you see that is that Apstra is actually going through it's creating configurations, and then it's going through and verifying all of those configurations. So if there's anything that the validators that we have built in don't like, they'll inform you of that. And usually when I do these very random things, I manage to make some kind of a mistake that a validator will come back and say, hey, there's a problem there. In this particular case, it didn't. But one of the things I do want to show you here is that now with this configuration, I can, for example, go to a specific node. In this case, I'm going to go to leaf 1 of server rack 1. And what I can see here is that this is an incremental configuration. This is what, in those very few clicks that I made, Apstra created. And I can see just by a quick glance, if you're familiar with Arista EOS, you'll know that this is an EOS configuration. And you can see here's my VRF blue that I created. Here's green. And all of the other information I need under there is created for me. So my VLANs are there. All of my BGP configuration is there. And just to show you very quickly, if I, for example, switch to border leaf 1, here, if I look at my incremental config there, you can see very quickly that's an NXOS configuration. Apstra knows that that border leaf is NXOS. So I have that all configured. All of my details are there. They're all validated. And so I know that's going to work. And I don't have to go through any of the minutia of actually physically creating this configuration and then labbing up the configuration and validating it manually. It's all done for me. And once I have verified everything, I would go to the committed tab, hit commit, and that commits all of my changes. If you're familiar with Juniper, Junos, you certainly are familiar with the idea of a candidate config, doing a commit, and then having an active config. And so that is the day 2 operations as far as just the day-to-day kinds of things you would do of creating new VRFs, creating virtual networks, and so forth. And I'm going to switch. This is a different blueprint. One thing I should say about this blueprint that I'm running actually in a server in my home office here is that at this point, I don't actually have any of these devices. I specified that I want, certain devices to be Arista, certain devices to be Cisco on here, and some Juniper devices. I don't have any of those installed yet. I've created all of that specification in preparation for actually installing the devices. I have a cable map that I can now connect all my devices together. I've got all of my logical configurations done. And when I bring the devices up under Apstra control, I then just push all of that out to the devices. This particular blueprint here, it's a little bit simpler blueprint with 2 spines and 2 racks, one with 2 top of rack leaves, one with a single top of rack leaf. And in this case, these are all Juniper devices, and there is Junos running underneath this. And as a result, you can see that there's some differences at the top here, where on my other blueprint, dashboard, analytics, and active actually said NA. They're green here. What I wanted to show you here very quickly is if I go to analytics, and interestingly enough, there are 3 anomalies. It says that I have some systems with high CPU utilization. That actually surprises me. I'm not sure why that's going on in my lab, but nevertheless, it's a good thing to go to show that Apstra quickly shows you those kinds of anomalies. But another part of what I would want to do as part of my day-to-day operations is gather information about my network. So for example, if I go to device traffic, I can very quickly display and there's not really much going on in this network. So pretty much everything shows 0 packets per second. But very quickly, I can see what's going on in my network in terms of traffic bandwidth utilization. Another thing that I could do, and by the way, you do all this by creating probes. Maybe I need to see some information about critical services. And so I can very quickly select a probe on critical services. And then this is something I did ahead of time on all of my servers. I specified what kinds of services are running on those services. So in this particular case, I might want to say that I want to know what my critical services are doing for my app development, and maybe for, I have a test network, and maybe for finance. On those particular applications, I want to create a probe, and it takes a minute, but what I have now, again, not really anything going on in the network, is very quickly I can look and see for those critical services that are running in my network, what my bandwidth utilization is, where they're running, what interfaces they're running on, and so forth. And there are a lot of variables that I can set to query what's going on in that network. There's also a lot of variables about how to query the network. The last thing I want to show, because I know we're quickly running out of time here, is within analytics and also on the dashboard. I could very quickly see what's going on in my network. So when there are anomalies, and interestingly enough, let's just click on that anomaly because I'm not sure what's going on there. Oh, you can see there was, in this particular case, for device system health, it's saying that I have some CPU utilization that's running beyond, and it's on these specific devices. Actually, that's all my devices. I'm running at 27%, and I had a threshold saying, let me know when my CPU utilization gets beyond a certain point. But with a longer demonstration, what I normally like to do here is sort of go in the background and create a problem on the network, and then show how quickly I can go through and troubleshoot that problem and literally resolve the problem in just a minute or two. But given our time limitations here, I'm going to stop at this point. Maybe one thing else to show, because this is something that Majid pointed out, is our theme here is managing complexity. And if I actually, again, you can see this very simple network that we have here. In the background, Apstra is tracking this network in a graph model. And I could actually look at that graph model. And again, just showing that this is a extremely simple network. And yet, here's the graph model for actually tracking that network. And you can see that this is something that's tremendously complex here. And so this is something that's all being worked in the background and would be almost impossible to completely manage if you're trying to do all this manually. So I did want to point that out, because I feel like there's a lot that I could say about this graph model, but there's a lot I could say here in terms of managing complexity. But I wanted to at least show that to you. And at that point, Majid, I'm going to throw it back to you. And maybe at this point, we want to open up for questions.
Yep. No, sure, Jeff. I think we can certainly open up for questions real quick. I think in summary, I want to say, for our quick discussion today, we kind of highlighted that, EVPN-VXLAN is a technology that offers you an efficient and scalable L2 and L3 connectivity. but in order to manage your fabric, right, you need a sophisticated solution. And then just not any solution, but you would need a unified solution for seamless automation from day 0 to day 2, so that your architects and operations guys can see through the same pane of glass, right? And based on what Jeff showed you, and then the things that we talked about, I think we'll all agree that Juniper Apstra actually does meet all the requirements of an effective fabric management solution, and then does it in a way that it helps you do more with less, and then grow without growing pains. And then in addition to that, if you want to know more or learn more, we actually have free resources on Juniper website. We have a training portal. We also have virtual labs. And then there's a fantastic YouTube list where you can actually see videos like this on how Apstra can help you with your fabric management. So I'll conclude with that. And last thing is that we're actually going to have more lightning sessions like this about how Apstra can help your day 2 operations, or how it can help integrate with your existing fabric. So please tune into those as well. So Jeff, before we close, any closing comments from you?
No, other than just saying, if you'd like to see a more extensive demonstration of Apstra, I'm always available to do that.
Definitely. Thank you, Jeff, and thanks for joining, folks. We'll look forward to talk to you more.